Hey there, micro friends. Welcome to another episode of Let's Talk Micro. As always, I am so happy that you're here with me. And if this is the first time you're listening to Let's Talk Micro, well, thank you for choosing it as one of your podcasts. And I know you're tuning in because you want to learn more about gram-negative cocci, so let's go ahead and jump on it. So, this is the third episode of a series about gram-negative cocci. And the goal of this series is to make us a little bit stronger when it comes to gram-negative cocci. Sometimes, it can be scary identifying them in the lab, especially when you see a gram stain. You might be a little hesitant to call it, right? So, at least by making sure that we have as much knowledge as we can, as much repetition as we can, and that is going to help us build confidence, which is something that's very important when you work as a microbiologist, right? You have to be confident, of course. You have your knowledge, your education, repetition, and those things, they build confidence. And that's something that you have it. And of course, I'm not saying that you never question anything. Of course, if you're not sure about something, please consult. Consult with a more experienced tech, consult with a supervisor, a director. But if we don't have confidence, then that means that we're gonna hesitate a lot on our day-to-day work, and that's gonna make for a very long day. So this series, it's meant to help us with that, to learn more about gram-negative cocci. And for the benefit of those that are tuning in for the first time, the first episode focused on the gram stain and the different genera and species. And I also went over some sites where you can expect to see gram-negative cocci. Of course, we have two major genera, which are Moraxella and Neisseria, and we know that there are some species within this genera that are gram-negative rods. But we are focusing on the gram-negative cocci ones. For example, Neisseria gonorrhoeae, Neisseria meningitidis, other Neisseria such as Lactamica and Zika, and then of course for Moraxella, Moraxella cataralis. And we also focus on some anaerobes. So we talked about Violinella, and we also mentioned some other species. And with those, we are not spending as much time as with Neisseria gonorrhoeae, for example, and Moraxella cataralis. Because Neisseria and Moraxella, they have some very significant diseases that we want to make sure we spend some time on. Okay, and that was episode one. And then on the last one, we focus on media and testing. And at the same time, going over some concepts that if you're preparing to take your certification as a medical lab scientist, either like ASCP, maybe AMT, some of these concepts are very important to know because you might get some questions. With this type of examination, it's always good as you're reading things, making those connections where you have those case studies and you look for those classic things. So, for example, we say hockey puck, you think Moraxella cataralis, things like that. So, talking about the media, we went over some types of media that are helpful to isolate organisms like Neisseria gonorrhoeae and Neisseria meningitidis. One of them being modified Thayer Martin, which is selective and enriched. And the enriched portion, it's a chocolate agar, and the selective portion, it's made of antimicrobials. For example, we talked about colistin, trimethoprim, vancomycin, and nystatin. So make sure you go ahead and review those. And one thing we talked about, speaking about examinations, we talked about Neisseria gonorrhoeae needing carbon dioxide to grow. And sometimes, the transport of the sample to the lab can be challenging sometimes, how microbiology labs are nowadays, where you have like a centralized lab that does most of the micro for other hospitals. So sometimes the transport time, it can be delayed. And this might affect the chances of you recovering this organism if that's what you're looking for. So there's a system that we talked about called JEMBEC, JEMBEC, which is a system for transport. So those two episodes are packed with information, so definitely go back and check them. Okay, so by now you know the media that the different gram-negative cocci grow on. You also know the sources where you can potentially find these organisms. And this is something that's very helpful because by knowing these sources, right, you can expect some of them in some areas. Like if you're looking at a respiratory sample and you see gram-negative cocci, that's expected because non-pathogenic Neisseria is part of the respiratory flora. And in other sources, even though they might not be there all the time, but at least if you have a particular source and you see them, you're like, okay, this organism, when it is seen, you see it in this area. While there are some Neisserias, like non-pathogenic Neisseria, that are part of the respiratory flora, There are some Neisserias that are pathogenic, for example, Neisseria gonorrhoeae. And in the lab, you can get cultures just to rule it out. And it can be from many sources. Based on what we have discussed, sources are typically genital, throat, and eye. And with this type of culture, you get a chocolate plate and a modified Thayer Martin. Now remember, just because something is growing on modified Thayer Martin, it does not mean that it is Neisseria gonorrhoeae or Neisseria meningitidis. The gram stain is always your best friend. If you perform one and see gram-negative cocci, you still need to sub it to media where you can properly identify it. And that brings us to today's episode, in which I am going to be mentioning some instruments and tests, and it does not mean that I am endorsing these products, but they are commonly used in the lab. So by now you have a gram-negative cocci. You look at it on the plate and you are confident it is gram-negative cocci. Maybe you're not, right? We've been talking about how daunting it can be. But in this scenario, you know what it is. You went for it. You're confident. This is what it is, gram-negative cocci. Now it is time to prove it, which means it is time to identify it. Okay, so let's go ahead and start with the easiest one. And those of you that work in the lab, you know that it's easy to identify a Moraxella catarrhalis. You don't even need VITEK or MALDI-TOF. You see those gram-negative cocci. The colonies slide around the agar. Oxide is positive. You do what? A catarrhalis disc, right? And that's it. Once that reaction is positive on that disc, you can go ahead and call it Moraxella catarrhalis, and then you're done. That catarrhalis disc is a very easy test. It doesn't take a long time. So let's go ahead and talk about tests or instruments and identifying methods that take longer. So of course you have your classic VITEK NH card. It identifies Neisseria gonorrhoeae, meningitidis, Zika, lactamica, Syndromic, and Moraxella catarrhalis. And those of you that work in the lab know that one of the drawbacks of this card, compared to other methods, is that it requires a larger amount of organism. And we have talked about this in the podcast before. For this card, you need a suspension of 2.7 to 3.3 McFarland standard. That is a heavy inoculum, so you definitely need more colonies. And that means if you have the organism mixed with others, you might have to isolate it first so you can have enough to run it on the system. So, bottom line, results take longer than other methods. One thing that is mentioned for this card is that Neisseria flavescens or mucosa might be misidentified as Neisseria sicca, but it mentions in the package insert some tests to rule them out. Then you have the RapID NH system. And those of you that have been listening to for a while, I have talked about this system, especially when it comes to anaerobes. There are several rapid tests like this. There's like a panel for anaerobes, which is commonly used in labs, which is the rapid ANA panel. There's one for Corynebacterium. We used to have one in the lab before for like Enterococcus. So these panels are, they're small. You can hold them in your hand. And they have like a series of wells, and you make a suspension, and then you put specific amounts in the wells. And then you incubate for 4 hours. And at the end of that time, then you observe for different colors. Some of the wells you have to add reagents and then observe for color changes. And then based on that, you have positive or negative reactions, which is going to give you a numeric code. And then you go into the software for this test and you enter that code and you get an ID. And this RapID NH panel, it's a small panel for Neisseria, Haemophilus, and Moraxella. So you have that numeric code, you put it in the system, in the software, and then you get that ID. For example, Neisseria gonorrhoeae, Neisseria meningitidis, Moraxella catarrhalis. Now the test takes 4 hours. So it is something that you can set it up in the morning and then at lunchtime read it, which is what typically people do, right? They go over, especially when it comes to anaerobes, you look at them, you set up your test in the morning and then at lunchtime read them. And for small labs, I think this makes sense, based on space, the cost of having something like MALDI-TOF. But what I don't like about this test is that people play with the numbers, meaning you get like an unidentified result, or you get a weird ID, and then you go back to your test and you go, okay, well, this was a positive, let's try a negative. Or even when you're looking at the test and you're not sure, maybe you put like a star next to it, either positive or negative. So you play with those interpretations to change the numbers. And sometimes you get an ID. So it's too subjective. So that's what I don't like about it. But that is my opinion. And then, of course, there is MALDI-TOF, which we did some episodes here in Let's Talk Micro. So I invite you to check out episode 112 and 115 to learn more about MALDI-TOF MS. And in a nutshell, right, you have a slide, you put your sample there, you add a substance, and then a laser is pointed at the sample. And then that substance, what it's going to do, it's going to ionize the molecules. And then the molecules, they travel through a tube, and then the time of flight is measured, and then a spectrum is produced, and that is compared to a database of known spectra, and you get an ID. Of course, with Molotov, you get a result so fast, and then you have a larger database of organisms. You need less organisms, like one or two colonies is enough. So unless it's very mixed, if you are able to see the colonies and you have enough, isolated ones, you can go ahead and do the MALDI and get your ID. And with this database of organisms, with MALDI, something to keep in mind is that in this database, you have some organisms that have been cleared by the FDA and some haven't. So, what I mean by clear, they have been cleared for clinical diagnostics. And those that have not been cleared, they are called non-claim. And those of you that use MALDI, you see that the organism has like an N in parentheses next to the name of the organism. And this is basically that they haven't been validated. So, but that is something that you can do in your lab. So you get that ID and then you test that organism via other methods. And then you get an X number of samples. And then you are able to utilize that ID. So all you have to do is a validation, right? Some organisms are more difficult than others, right? Because systems like the VITEK and things like that, you have limited databases. So you might have to send some maybe through gene sequencing. You might have to send them to another place for that. But other ones that you see daily in the lab, like Ericoccus urinae, that's one that shows as non-claim, and you can do a validation because VITEK can identify it. So that's a little bit easier than other organisms. Anyway, that N in the parentheses for non-claim is not gonna go away. But once you have done your validation and you have a list in your workspace, you can go ahead and release that ID. Something very important to remember is that when you are doing this validation or you have a sample that you're running it, you get a non claim organism, and then you decide to run it in another platform. To confirm that ID, you have to make sure that that organism, that ID, is in the database of that other instrument. For example, if you go to the VITEK and then you check a specific card, like a specific identification card, go over and check the list of organisms that it can identify. Because if the organism that you're trying to confirm is not in that system, like that VITEK card, you can get an erroneous ID. Maybe you can get another species, but maybe you can identify it as something else altogether. So you have to make sure that that particular organism is on that database. Okay, so by now we have discussed how to identify them once you have grown them in the lab, right? You went through the putting it on media, you grew it, you isolated it, you identified it, and you're good. How about from direct samples? Well, if you work in the microlab, you know that a lot of testing for Neisseria gonorrhoeae is done via molecular methods. Neisseria meningitidis, as we have discussed, is an organism that is seen in meningitis, which is very critical. So if you have a meningitis panel in the lab, like a PCR panel, it makes sense to have Neisseria meningitidis in this panel. And I will talk about this in a few minutes. But let's go ahead and talk about some tests where we can identify gram-negative cocci without culture. Like, for example, from a cerebrospinal fluid where the clinical presentation looks like meningitis. So the provider wants to rule out an agent of meningitis, or a blood culture where you see this gram-negative cocci, or another source where the doctor wants to rule out something like Neisseria gonorrhoeae. So let's talk about those tests. And that is where syndromic panels and nucleic acid amplification tests really come into play. So let's start with blood, right? Definitely in a microlab, you have a blood culture instrument, either like a virtual or a BDFX. And then, very typical, right? That bottle is flagged as positive. You do a gram stain. Depending on what you see, you set up one of these blood culture identification panels. One example is the BioFire BCID2 panel. And in this panel, you have multiple targets. So one panel, you have bacteria, you have fungi, and resistant markers. And in this panel, one of the targets is Neisseria meningitidis. So if it's present, you can get that ID. So before, in the case of blood, because in the lab, you plate it, you do a culture, but before you do this and recover the organism, you can have that ID and give it to the physician so they can start treatment. And there are other systems that do this as well. For example, the EPLEX, blood culture ID panels. And these ones, you do detect the same, like bacterial pathogens, fungal pathogens, resistant markers. But in the case of the EPLEX, you have different test panels, one for gram positive, one for gram negative, one for fungi. Then another example of a test system is the Verigene from Diasorin. Same thing, you have like a gram positive panel, you have a gram negative panel. So these systems, they are very helpful because you can get an ID right away. But something to keep in mind that for these instruments, for these systems, you you test them on a blood culture that has already been flagged positive. It's not like you collect it in a blood culture bottle and then you go ahead and run the test, right? You have to put it on the instrument first. So the Eplex and the Verigene, they have targets for Neisseria meningitidis. Now let's switch to cerebrospinal fluid. A great example is the BioFire meningitis encephalitis panel, where you take the CSF, right? You collect it, you take the CSF, you load it into the cartridge, and then the system tests for a panel of bacterial, viral, and fungal causes of meningitis. So this panel has a target for Neisseria meningitidis. And of course, you have other bacterial pathogens that are seen in meningitis. You have Streptococcus agalactiae, Streptococcus pneumoniae, Listeria monocytogenes, Haemophilus influenza, E. coli. So this is a widely used panel, and it is very helpful in the identification of organisms that are seen in meningitis. And this panel can detect that meningococcal DNA from CSF even if the patient already received antibiotics and the culture might end up negative. Which is something to keep in mind when you're doing molecular tests like PCR and things like that you have to keep in mind that the organism might be non viable, so you might not recover in a culture. Okay, so before we continue going, let me talk a little bit about nucleic acid amplification test or NAT. And basically, for the acid amplification test, you extract the nucleic acid, you amplify a specific target using a method like PCR or transcription mediated amplification, and then you detect that amplified product with a probe or a fluorescent signal. And then if that target is present, the signal lights up and the instrument calls it positive. And this is something that happens in a closed system, which is very cool. And a lot of these tests that I'm talking about, sometimes some of them are quite small and they are closed systems. And of course, the advantages of this type of test is that, there is sensitivity and speed. You don't need viable organisms. And you can get answers in about an hour or two instead of waiting, for example, 24, 48 hours for a traditional culture. And that is huge when you're dealing with Neisseria meningitidis in CSF or Neisseria gonorrhoeae on a genital side, let's say. I mean, something like meningitis is very critical. So you getting that identification so quick instead of 24 to 48 hours, is very important. That way, the physician, the healthcare provider can start treatment. Now, of course, with that is a trade-off that, as I mentioned, right, you're using the sample and not an organism that you have grown in culture. So you're not going to get susceptibilities from that. So if you are looking for some specific drugs, some specific antibiotics, then you have to do a culture and test for that. Okay, so now that we have a better understanding of what gnats are, then we can see how helpful they are. And I mentioned, I talked about Eplex, I talk about BioFire and things like that, and multiple targets. So with these, nucleic acid amplification tests, you have this syndromic panels where you're having, multiple targets, as I mentioned, with meningitis like Neisseria meningitidis, Haemophilus influenza, Listeria. With the blood cultures, you have the resistance markers. With some of these panels, you have things like VAN-A and VAN-V for vancomycin resistance, and MAC-A and MAC-C for oxacillin resistance, and KPC and NDM for carbapenem resistance. So these tests, they are very helpful. They provide quite a deal of information. And, we talked about blood and we talked about CSF, and then we have this other nucleic acid amplification test for like Neisseria, gonorrhea, and chlamydia. And those are very classic. And I'm sure as you're listening, you're familiar, at some point in time in the lab, you have tested one of this like Neisseria, chlamydia panels. They come together and you test for both. And some examples are like the systems like Aptima, Cobas, Abbott, GeneXpert, BDMax, which can detect Neisseria gonorrhea directly from urine and mucosal swabs. And those are usually validated for genital, rectal, and pharyngeal specimens. So they are very common in the lab. And then if you have something like a joint fluid or another type of body fluid, for those you might have to do like a culture. Or maybe if you're thinking of a disseminated infection, then maybe try to find like the source of the portal of entry. And based on that, decide, which test is right for that. Okay, so let's go ahead and do a quick recap, right? So when we want to identify gram-negative cocci, typically, if you have grown them in culture, you have things like VITEK and RapID NH, you have MALDI-TOF, which I know we have been focusing on Neisseria and Moraxella. But for MALDI-TOF, with MALDI-TOF, you can identify Veillonella also. And then when you have samples like a blood culture or a cerebrospinal fluid or another source where you are thinking of this organism and you want to rule it out, or you need to rule it out, then you have things like blood culture ID panels that can identify Neisseria meningitidis. You have the meningitis panel for Neisseria meningitidis. And then you have those chlamydia, Neisseria gonorrhea, nucleic acid amplification tests that let us detect gonococcal DNA from mucosal sites. Okay, so by now we have gone over testing, identification. So next thing we'll be talking about the different, genera and species of gram-negative cocci in a little more detail. And that is what the next episode is about. Well, there you have it. I hope you enjoyed this episode. As always, I enjoy sharing this information with you. So please stay tuned. This is content that's very important for those of us that work in the bench. And, even if you have your experience, a good refresher always comes in handy. So thank you for listening. And speaking of listening, of course, you can find us on any podcast platform. So if you go to Apple, Spotify, Amazon Music, Good Pods, you can find us there. So please subscribe to the podcast, download episodes, and the app allows you to do so. Please leave a review. Thank you so much for the support. And of course, in socials, you can find us. If you go to Instagram, TikTok, YouTube, Blue Sky Social, we're there as Let's Talk Micro, on X as Let's Talk Micro 1, LinkedIn as Luis Plaza. Then there's a website, letstalkmicro.com, where you can find information about study resources, licensing information, episode updates, and more. And there's an email, which is letstalkmicro@outlook.com. So either via social media, the website, email, you can send any feedback, any suggestions. Those are always welcome and appreciated. If you want to support us in any way, you can do so via Venmo or via Buy Me a Coffee, KOFI, and both links are available on the show notes. And friends, you know that as microbiologists or other members of the infectious disease community, one of the challenges is learning about antibiotics. So if you would like to learn more about antibiotics, please check out www.learnantibiotics.com and the Learn Antibiotics book, available on Amazon. These resources include cheat sheets, practice tests, games, and more, and they are being used by thousands of people worldwide and may be helpful for you or your colleagues. And as always, these are some great resources from Dr. Timothy Gauthier, a very passionate pharmacist. And the Let's Talk Micro podcast is supported by the American Society for Microbiology. To learn more about microbes, visit asm.org. And that, micro friends, it's the end of this episode. I hope you enjoy learning about gram-negative cocci and how to identify them. As always, I enjoy sharing this information with you. Hey, thank you so much for the support. Stay tuned. Great things coming your way. As always, please continue bringing that passion to what you do. It's so important. You do such great work. So, as always, stay motivated, stay safe, and of course, continue talking micro. Until the next time, bye.